The day the sun vanished, the world began to die. Not quickly, not mercifully, but slowly, agonizingly, as ash filled the sky and turned noon into twilight. As crops withered in fields that would never see harvest. As children huddled in caves, their eyes searching the gray horizon for warmth that would not come. This isn't mythology. This isn't legend passed down through firelight stories. This happened. 74,000 years ago, the Earth nearly ended. And with it, humanity came within a breath of extinction. Imagine standing on the shores of what we now call Sumatra. It's a warm morning. The sun climbs over volcanic peaks that have stood for millennia. Your ancestors, Homo sapiens, anatomically identical to you and me, are gathering food, making tools, telling stories in languages we'll never recover. They don't know they're living on top of a bomb. Beneath their feet, a magma chamber the size of a small country has been filling for hundreds of thousands of years. Pressure building, rock melting, the Earth's crust stretching thinner and thinner, like skin over an infected wound about to burst. Mount Toba isn't just a volcano. It's a supervolcano, a classification we reserve for the most catastrophic eruptions imaginable. The kind of geological event that rewrites the planet. The kind that makes the word disaster feel inadequate. To understand what a supervolcano is, you need to understand scale. A regular volcanic eruption, even a large one, involves a single vent or cone ejecting material. Destructive, yes, but localized. Supervolcanic eruptions are different. They empty entire magma chambers in one catastrophic release. The ground collapses inward, creating massive calderas, collapsed craters, that can span dozens of kilometers. Toba had erupted before. Smaller eruptions over the millennia, but nothing like what was coming. On this particular morning, around 74,000 years ago, the Earth's crust finally gave way. And what happened next was beyond human comprehension. The explosion was heard thousands of miles away, but most who heard it wouldn't live to remember. 2,800 cubic kilometers of rock and ash exploded into the atmosphere. To put that in perspective, that's enough material to bury the entire United States under half a meter of debris. It's 3,000 times more powerful than Mount St. Helens, 6 times larger than any eruption in recorded history. The energy released was equivalent to 1 billion tons of TNT, a million Hiroshima bombs detonating simultaneously. The blast column rose 50 kilometers into the stratosphere, higher than where jets fly, higher than the ozone layer, reaching toward the edge of space itself. At the base of this column, temperatures exceeded 1,000 degrees Celsius. Rock liquefied. The air itself became a weapon. Pyroclastic flows, superheated clouds of gas and rock moving at hundreds of kilometers per hour, swept across the landscape. These aren't the slow-moving lava flows you might picture. These are avalanches of death moving faster than hurricanes, hotter than cremation furnaces. Everything within 100 kilometers was incinerated instantly. Animals, forests, rivers boiled in their beds. Their water flash vaporized before the flows even arrived. The sound alone could kill. The shockwave traveled at supersonic speeds, rupturing lungs, collapsing structures that early humans might have built. Those who survived the initial blast would have been deafened, disoriented, unable to comprehend what had just torn their world apart. But the real horror wasn't the explosion itself. It was what came next. Within hours, the ash began to fall. Not just around Sumatra, not just in Southeast Asia. Everywhere. The stratosphere became a highway for destruction. At that altitude, above the weather, above the clouds where rain could wash particles down, the ash and aerosols could travel unimpeded. Winds caught the debris and spread it across the planet like ink dropped in water. The jet stream became a conveyor belt of catastrophe. Within weeks, every continent was blanketed. Ash layers 15 centimeters thick have been found in India, over 3,000 kilometers away. That's not dust. That's a geological burial. Marine sediment cores from the Indian Ocean show the chemical signature of Toba ash, a gray fingerprint of catastrophe preserved in rock. Scientists can identify it by its unique chemical composition, the ratio of specific elements that mark it as distinctly Toba. In Malaysia, ash deposits reach 9 meters deep in some locations. 9 meters. Imagine standing in a 3-story building made entirely of volcanic ash. Entire landscapes disappeared beneath this gray blanket. Forests suffocated. Animals buried alive. The archaeological record shows a clear demarcation. Life before the ash layer, and then nothing. An empty zone. A pause in the fossil record. But ash was just the beginning. The sulfur dioxide, 20 billion tons of it, reacted with water vapor in the stratosphere to form sulfuric acid droplets. These aerosols, microscopic but innumerable, created a reflective haze that wrapped around the Earth like a shroud. Each droplet acted like a tiny mirror, bouncing sunlight back into space before it could warm the planet. This is the mechanism that triggers volcanic winter. Not the ash itself, that falls relatively quickly, but these sulfate aerosols that can persist for years in the stratosphere. The temperature began to drop. Not gradually, not gently. Within months, global temperatures plummeted by as much as 15 degrees Celsius. In some regions, particularly in the northern hemisphere, the cooling was even more extreme. Ice cores from Greenland show temperature drops of up to 20 degrees. Lakes that had never frozen suddenly became solid. Tropical regions experienced frost. Snow fell in places that had never seen it. To understand what this means, consider that the difference between our current climate and the depths of the last ice age is only about 5 to 6 degrees Celsius globally. Toba dropped temperatures by 3 times that amount in a fraction of the time. The climate system, which normally changes on scales of centuries or millennia, was shocked into a new state within years. And this wasn't a winter that lasted weeks. It lasted years, perhaps a decade of severe cooling, perhaps longer. The aerosols stayed suspended in the stratosphere, continuing to block sunlight, continuing to cool the planet. Models suggest it could have taken centuries for the climate to fully recover. Some estimates put the cooling period at up to 1,000 years before temperatures returned to pre-eruption levels, though the full millennium might have involved gradual recovery rather than constant extreme cold. Picture it. Gray skies stretching to every horizon. Dim, perpetual twilight. The sun reduced to a pale disk behind the haze, if it was visible at all. Colors leached from the world. No blue sky, no vibrant greens, just shades of gray and brown and ash white. Temperatures that turned tropical forests into frozen wastelands. Rain that fell acidic, burning what little vegetation remained, leaving dead zones where nothing could grow. The sulfuric acid in the atmosphere didn't just block light. It poisoned water sources. It corroded surfaces. It made the air itself caustic. Breathing became difficult. Eyes burned. Skin developed lesions. The world had become hostile to life at the most fundamental level. This is what the world looked like after Toba. This is the world humanity had to survive. And most species didn't. When the sun disappears, everything else follows. Plants die first. They have no choice. Photosynthesis stops. Without sunlight, even the hardiest vegetation begins to wither within weeks. Tropical jungles that thrived in warmth and light turned skeletal. Leaves fell. Growth ceased. Trees stood leafless, their branches reaching toward a sun they couldn't find, like hands grasping for something forever out of reach. Grasslands became dust bowls. Without root systems to hold the soil, wind erosion accelerated. The ash layers, when dry, lifted into the air again, creating secondary dust storms. The landscape became a shifting, hostile desert of gray powder. Scientists have studied pollen records from this period, microscopic grains preserved in sediment that tell us what plants existed when. The data shows a dramatic shift. Species that dominated before Toba simply vanish from the record. They're replaced, sometimes centuries later, by different species, opportunistic plants that could colonize the devastated landscape. In some regions, forests never returned to their previous composition. The Amazon rainforest, which had been continuous across South America, fragmented into isolated pockets. These refugia, small areas where conditions remained marginally suitable for survival, became the only places where certain species persisted. Everything outside these zones died. The collapse moved up the food chain like dominoes falling. Herbivores starved. Without plants, there was nothing to eat. Fossil records show mass die-offs during this period, species that had survived for millions of years suddenly vanishing. Large mammals were hit especially hard. An elephant needs to eat hundreds of pounds of vegetation daily. A mammoth even more. In a world where food had become scarce beyond imagination, size became a death sentence. Megafauna, The large animals that dominated ecosystems went into steep decline, not just from starvation, but from the cascade effects. When food is scarce, reproduction slows. Infant mortality rises. Social structures break down as desperate animals compete for dwindling resources. Species that had thrived for eons found themselves unable to adapt quickly enough to the new reality. Carnivores followed. Predators depend on prey populations, and when those populations crash, predators crash harder. The ratio is brutal. It takes roughly 10 pounds of prey to sustain 1 pound of predator. When herbivore numbers collapsed, carnivores lost their food source. Lions, tigers, wolves, the predators of the Pleistocene, faced starvation. The African savanna, once teeming with life, became a graveyard. Bones scattered across a landscape that could no longer support them. Even scavengers struggled. When there are no dying animals, there's nothing to scavenge. And the oceans weren't safe either. Cooling temperatures disrupted ocean currents. The thermohaline circulation, the global conveyor belt of ocean water that distributes heat and nutrients, weakened or shifted. Upwelling zones, where deep, nutrient-rich water rises to feed surface ecosystems, were disrupted. Nutrients that normally circulated from deep waters to the surface stopped flowing. Plankton populations collapsed. These microscopic organisms form the base of the marine food web. When plankton dies, everything that depends on it dies too. Small fish that eat plankton, larger fish that eat small fish, whales, dolphins, seals, entire marine ecosystems unwinding from the bottom up. Coral reefs bleached and died. These structures, built over millennia by tiny polyps, are sensitive to temperature changes. The cooling shocked them. But so did the reduction in light penetrating through the ash-darkened atmosphere. Reefs that had been vibrant with life turned to lifeless calcium skeletons. Scientists estimate that up to 75% of all plant species in the northern hemisphere died during this period. 3/4 of all vegetation gone. In the tropics, the numbers were somewhat better, but still catastrophic. Entire biomes ceased to exist. The world's biodiversity, built over millions of years of evolution, was decimated in less than a human lifetime. But perhaps the most haunting part wasn't what died. It was the silence. No bird calls at dawn. No insect hum in the evening. No rustle of life in the underbrush. No howls of predators. No splash of fish in rivers. Just wind, and ash, and cold. The world had become a mausoleum. Somewhere in this dying world, our ancestors were trying to survive. Before Toba, humans were doing well, relatively speaking. Homo sapiens had emerged in Africa perhaps 300,000 years earlier. We'd developed sophisticated tools, complex social structures, symbolic thinking. We'd migrated across much of Africa and into parts of Asia and possibly early Europe. Our population was growing. We were successful. And then Toba erupted. Genetic evidence tells us something extraordinary and terrifying about this moment in our history. Around 74,000 years ago, the human population crashed so severely that we nearly went extinct. The proof is written in our DNA. When scientists analyze human genetic diversity today, they find something strange. Compared to other species, chimpanzees, gorillas, even wolves, humans are remarkably similar to each other. Two humans chosen randomly from opposite sides of the planet are more genetically alike than two chimpanzees from the same forest in Africa. We're all, genetically speaking, close relatives. This is called a genetic bottleneck. It happens when a population shrinks so drastically that genetic diversity is lost. Think of it like this. Imagine a bag full of different colored marbles, red, blue, green, yellow, dozens of colors representing genetic variants. Now imagine randomly grabbing just a handful. You might get mostly red and blue, losing all the other colors. When the population expands again from that handful, everyone descends from just those few colors. The original diversity is gone, lost in the bottleneck. That's what happened to humanity. How small did we get? Estimates vary depending on the genetic models used, but the numbers are sobering. Some studies suggest the global human population may have dropped to as few as 3,000 to 10,000 individuals. Other analyses push the number higher, perhaps 15,000 to 20,000. But even at the upper estimate, that's terrifyingly small. To put that in perspective, that's smaller than the population of most small towns. The entire human species, every future scientist, artist, explorer, philosopher, everyone who would ever live, reduced to a number that could fit in a large high school. Spread that across Africa and scattered parts of Asia, divided into small bands of maybe 20 to 50 individuals each, and you get a picture of just how isolated and vulnerable we were. Groups separated by vast distances, many probably unaware other humans even still existed. We were on the edge. One more winter, one more failed harvest, one more cold season where children didn't survive, and we would have joined the list of extinct hominins. Like Homo habilis, like Homo erectus, like the robust Australopithecines. Gone. Another failed branch on the evolutionary tree of life. There were other human species at this time. Neanderthals in Europe and Western Asia. Denisovans in Eastern Asia. Homo erectus possibly hanging on in isolated pockets of Southeast Asia. They faced the same volcanic winter. They went through the same bottlenecks. But they had smaller populations to begin with. They were more specialized, adapted to specific environments. When those environments changed catastrophically, they had less flexibility, fewer options. The genetic evidence suggests they were hit even harder than Homo sapiens. We all nearly died together. But somehow, we, Homo sapiens, didn't disappear. The question that haunts anthropologists is, why? What did we have that others didn't? What allowed us to cling to survival when so many other species, including our closest relatives, failed? How do you survive when the world ends? The answer is written in archaeological sites scattered across Africa and a few precious locations beyond. Stone tools found in coastal caves. Evidence of shellfish consumption increasing dramatically during this period. Remnants of ochre, used for everything from sunscreen to adhesive to symbolic purposes, showing that even in the darkest times, humans were still humans. Still thinking, still adapting, still creating, still hoping. Some researchers believe coastal regions became refuges. The ocean, despite its own disruptions, still provided resources that terrestrial environments couldn't match. Shellfish don't need sunlight to survive. They filter nutrients from water. Tidal pools still filled twice daily. Seaweed still grew in shallow waters. For humans living on coastlines, the sea became a lifeline when the land offered nothing. Archaeological evidence from Pinnacle Point in South Africa shows continuous human occupation through the Toba period. The people there were exploiting marine resources, shells, fish, seals. Their diet shifted more heavily towards seafood precisely during the time when terrestrial food sources would have been collapsing. This wasn't a coincidence. This was adaptation in real time. Coastal environments had another advantage. They were more climatically stable. Oceans store heat. They moderate temperature extremes. While inland areas might have experienced the full brunt of temperature drops, coastal zones would have been buffered. A few degrees difference could mean the difference between survival and death. Inland, survival was harder. Without the ocean's resources, people had to become more innovative. They dug for tubers and roots, underground plant storage organs that could survive when everything above ground died. They hunted smaller game, rodents, birds, reptiles, animals that could subsist on less and reproduce quickly enough to maintain populations despite predation. They learned to read the landscape with intense precision. Which valleys trapped warmer air? Which caves provided better shelter? Where underground springs still flowed when surface water froze? This knowledge wasn't written down. Writing wouldn't be invented for another 70,000 years, but it was passed down verbally, person to person, generation to generation. Knowledge became as vital as food. Fire became sacred, not just for warmth. Though in a world where temperatures had plunged, warmth meant life, but for cooking, for protection, for light in a world without stars. Fire allowed humans to process foods that would otherwise be inedible or dangerous. Fire kept predators at bay. Fire was a gathering point, a symbol of humanity persisting in the darkness. Archaeologists have found evidence of increased fire use during this period. More hearths, more burn bone, sites that show continuous occupation with fires maintained over long periods. Controlled burns, hearths dug deep and lined with stone to preserve heat. Fire that couldn't be allowed to die because starting a new one in wet, cold conditions might be impossible. The person who knew how to start fire, how to coax flame from friction or sparks, became invaluable. Tool technology, may have advanced out of necessity. Some researchers point to increased sophistication in stone tool assemblages around this period. Smaller, more precise tools. Back blades that could be hafted onto wooden shafts. Microliths that maximized utility from every piece of stone. When resources are scarce, efficiency matters. You can't afford to waste material or effort. Social bonds probably tightened. Small groups would have banded together, pooling resources and knowledge. Sharing food when one family succeeded in a hunt. Caring for each other's children. The evolutionary advantages of cooperation, always present, would have been amplified when the margin between survival and death was so thin. The elderly, those who remembered better times, who knew where hidden water sources were, who understood the patterns of animal behavior and plant growth, became invaluable. In a crisis, experience matters. The grandmother who remembered which tubers were safe to eat. The grandfather who knew how to track game in harsh conditions. These people were living libraries of survival knowledge. Children were protected at all costs because they represented the future, however uncertain. Every child lost was genetic diversity lost, knowledge not passed on, hope diminished. Childhood mortality, already high in Pleistocene populations, must have been devastating during the Toba winter. And language. Language would have been crucial. The ability to communicate complex ideas. There are tubers buried near the old tree. The fishing is better at dawn. Stay away from the northern valley. There's nothing alive there. Might have been the difference between groups that survived and groups that didn't. Some anthropologists believe the Toba catastrophe may have accelerated the development of complex language and symbolic thinking. When survival margins are that thin, every advantage matters. The group with slightly better communication, slightly more sophisticated planning, slightly stronger social cohesion, that group lives. That group's genes and their cognitive abilities get passed forward. We can't know what they sounded like, these languages spoken in the darkness. But we know they existed. And we know they were powerful enough to transmit the knowledge that kept humanity alive. But it wasn't just about physical survival. Humans are storytelling creatures. We always have been. Even in the darkness, we would have told stories. About the sun. About the time before the gray sky. About ancestors. About hope that warmth would return. About meaning in a world that seemed to have lost all meaning. Those stories, none of which survived in any form we can recover, kept our ancestors psychologically alive when everything else was trying to kill them. Because survival isn't just physical. It's mental, emotional, spiritual even. You have to believe tomorrow is possible to make it to tomorrow. Eventually, the sun came back. Not suddenly, not dramatically, but gradually, almost imperceptibly, as the sulfuric acid droplets in the stratosphere finally broke down under ultraviolet radiation and fell as acid rain. As the ash settled, as wind and weather slowly, patiently scrubbed the atmosphere clean. Year by year, the haze thinned. The sun grew brighter. Shadows returned, first as faint suggestions, then as distinct shapes. Colors came back to the world. Blue crept into the sky. Green returned to the earth. Temperatures began to rise. First at the equator, where sunlight was strongest, even filtered through the haze. Then spreading poleward as the aerosol layer dissipated. It would have been gradual enough that no single generation saw dramatic change. But over decades, over lifetimes, the world warmed. Ice sheets that had advanced retreated. Glaciers that had pushed into temperate zones pulled back. Rivers that had frozen solid began to flow again. Rain fell. Clean rain, eventually, as the acids were leached from the atmosphere, and the land remembered how to absorb it. And life, as it always does, found a way to return. Seeds that had laid dormant in the soil, some capable of remaining viable for decades, began to sprout. Not the old forests. Those were gone forever, their component species lost to extinction. But new growth. Opportunistic plants that could colonize bare ground. Grasses, shrubs, fast-growing species that could take advantage of disturbed landscapes. Over centuries, trees returned. Not the same trees. Not the same forest composition. Evolution had worked its brutal mathematics. The species that returned were the ones whose seeds had survived, whose populations had clung to existence in those scattered refugia. The resulting ecosystems were different, reshuffled decks of ecological cards. The Amazon, which had fragmented, slowly reconnected. But genetic analysis of modern Amazonian species shows the signature of that fragmentation. Populations that diverged during the Toba period and only later came back into contact. The forest healed, but it bears scars. Animals repopulate from small survivor populations. Species that made it through the bottleneck, the ones with genes for cold tolerance, behavioral flexibility, or just dumb luck, spread back into territories that had been empty. Evolution accelerated as natural selection worked on reduced populations. The survivors weren't just lucky, they were adapted. Their genes encoded lessons written in crisis. New predator-prey relationships formed. Ecosystem structures rebuilt themselves from the ground up. The process took millennia. Even as humans were building the first agricultural societies 10,000 years ago, ecosystems were still recovering from Toba. And humans? We spread too. Genetic evidence and archaeological finds suggest that after the bottleneck, after the worst of the Toba winter, human populations began to expand again. Slowly at first. Groups that had been isolated made contact. Populations that had huddled in refugia began to disperse as conditions improved. Some researchers believe that the Toba event, paradoxically, may have set the stage for humanity's eventual dominance. The survivors were the smartest, the most adaptable, the most cooperative. They carried genes for resilience, for creativity, for problem-solving under extreme pressure. Natural selection had run humanity through the finest filter imaginable, and what emerged was perhaps more capable than what went in. From those few thousand individuals, humanity rebounded. We migrated out of Africa, or remigrated. If earlier groups had been wiped out by Toba, we developed new tools, new strategies, new ways of organizing ourselves. We encountered and sometimes interbred with other human species like Neanderthals and Denisovans, those who had also survived in isolated pockets. By 40,000 years ago, humans were creating cave art in Europe and Indonesia. By 30,000 years ago, we were the dominant large predator on every continent except Antarctica. By 12,000 years ago, we were inventing agriculture. But we never forgot, on some deep level, what it meant to be fragile. Every human culture has flood myths, darkness myths, end-of-the-world stories. Maybe some of these, filtered through tens of thousands of years of oral tradition, carry whispers of Toba. Stories of when the sun died, when the world went dark, when everything nearly ended. We don't know. We can't know. But we know those stories exist. And we know they matter. Here's what keeps scientists awake at night. Toba wasn't unique. Supervolcanic eruptions have happened before. They'll happen again. Yellowstone National Park in the United States sits on top of a supervolcano. It's erupted 3 times in the last 2.1 million years. 2.1 million years ago, 1.3 million years ago, and 640,000 years ago. By some measures, it's overdue for another eruption, though geological timescales make such predictions fuzzy at best. When it does erupt, and it will eventually, the effects will be catastrophic on a continental scale. Ash would blanket much of North America. The climate effects would be global. Campi Flegrei in Italy, near Naples, is another supervolcano showing signs of restlessness. Ground deformation. Increased seismic activity. The last major eruption was 39,000 years ago, the Campanian ignimbrite eruption, which may have contributed to the decline of Neanderthals in Europe. Today, 3 million people live in the immediate vicinity. Lake Taupo in New Zealand. Taupo itself in New Zealand, which erupted 26,500 years ago. Era caldera in Japan. These aren't extinct, they're dormant. Sleeping. And geological sleep is not the same as death. We can't predict when the next supervolcanic eruption will occur. Could be next year. Could be 100,000 years from now. But the probability over long timescales is certainty. It will happen. And it's not just volcanoes. Asteroid impacts can trigger the same cascade of cooling and darkness. 66 million years ago, an asteroid roughly 10 kilometers in diameter struck what's now the Yucatan Peninsula in Mexico. The impact energy was incomprehensible, equivalent to billions of nuclear weapons. The blast created a crater 150 kilometers wide. But again, the immediate destruction was just the beginning. The impact vaporized rock, ejecting trillions of tons of debris into the atmosphere. Soot from global wildfires added to the darkness. The result was an impact winter similar to volcanic winter. Sunlight blocked, temperatures plummeting, ecosystems collapsing. The dinosaurs didn't survive that one. 3/4 of all species on Earth died. Could it happen again? Yes. We track near-Earth asteroids now. We've identified most of the large ones, those capable of global catastrophe. But most isn't all. And smaller asteroids, while not extinction-level threats, could still trigger regional devastation and climate disruption. In 1908, an asteroid or comet fragment exploded over Siberia near the Tunguska River. The airburst flattened 2,000 square kilometers of forest. Had it exploded over a city instead of remote wilderness, millions might have died. And we never saw it coming. We got lucky with Toba. Lucky that it happened when human populations were small and mobile. Lucky that we had the cognitive flexibility to adapt. Lucky that some regions, coastal areas, tropical refuges near the equator, remained marginally habitable. Lucky that we had fire, language, and cooperation. Would we be as lucky today? Imagine a Toba-scale eruption happening now. 8 billion people dependent on industrial agriculture. Supply chains that span continents. Delivering food just in time with no surplus. Cities with just days of food stockpiled in supermarkets. Power grids vulnerable to ash fall. Water treatment plants that would fail. Communication networks that might collapse. Modern civilization is incredibly efficient, but that efficiency comes with fragility. We've optimized for normal conditions. We have very little resilience built in for the abnormal. We're not prepared for the sun to disappear. 1 year of severe cooling, not even a full Toba-scale event, just one bad year, would devastate global agriculture. Wheat, rice, corn, all the crops that feed humanity require predictable growing seasons and specific temperature ranges. Move outside those ranges and yields plummet. 1 year of crop failures would empty warehouses. Food prices would spike. Nations would hoard. Distribution would break down. 2 years? 3. Unthinkable. And we'd have warning, yes. We monitor volcanoes. We'd see the eruption coming, probably days or weeks in advance. Long enough to panic. Not long enough to prepare. Climate scientists study Toba not just as history, but as a warning. Because volcanic winter, cooling triggered by atmospheric particulates blocking sunlight, looks disturbingly similar to some climate intervention proposals being discussed today. Schemes to fight global warming by intentionally injecting aerosols into the stratosphere. Solar geoengineering, it's called. The idea is that if we could create a mild, controlled version of what Toba did accidentally, we could counteract warming from greenhouse gases. Reflective particles in the stratosphere bouncing sunlight back to space. Sounds reasonable in theory, but Toba shows us what happens when you block the sun. Even partially, even temporarily. The ecological consequences. The climate disruption. The cascading failures. We're discussing doing to ourselves, intentionally, what Toba did accidentally. The difference is, we think we can control it. We think we're smarter than geological forces. We think we can tune the Earth's thermostat with precision. 74,000 years ago, the Earth proved how quickly that confidence can be shattered. Every human alive today carries the echo of Toba in their DNA. That genetic bottleneck, that moment when humanity was reduced to a few thousand people, left permanent marks. Our lack of genetic diversity compared to other species. Our vulnerability to certain diseases because we lost genetic variants that might have provided resistance. The fact that you can take two people from opposite ends of the Earth and find them more genetically similar than two chimpanzees from neighboring troops. We're all related. Not metaphorically. Literally. If you trace back your family tree, and your neighbor traces back theirs, and a person in China traces back theirs, eventually those trees converge. All roads lead back to Africa. Somewhere on that continent, sometime after the Toba eruption, sometime in the long recovery, we all share common ancestors. The people who survived. The ones who figured out how to live in a world without sunlight. Mitochondrial Eve, the woman from whom all modern humans inherited their mitochondrial DNA, lived around this period, perhaps 150,000 to 200,000 years ago. Y chromosomal Adam, the man from whom all men inherited their Y chromosomes, lived perhaps 200,000 to 300,000 years ago. These aren't the first humans. They're just the ones whose genetic lineages survived all the bottlenecks, including Toba, to reach us today. Every other lineage, every other family line from that era, ended, died out, lost to time and catastrophe. We are, all of us, descendants of survivors. Their resilience is our inheritance, but so is their luck. So is their vulnerability. Genetic studies suggest that the human species has experienced multiple bottlenecks throughout our evolution. Times when we were pushed to the brink and somehow clawed back. Toba might have been the most severe, but it wasn't alone. Around 900,000 years ago, the ancestors of modern humans went through another severe bottleneck. Populations might have dropped to as low as 1,280 individuals for more than 100,000 years. The cause is debated: climate fluctuation, environmental change, competition with other hominin species. But the genetic signature is clear. We nearly didn't make it. Each time, we survived by the narrowest of margins. How many times can you roll the dice before you lose? And here's the uncomfortable truth. Reduced genetic diversity makes us more vulnerable going forward. When a species has high genetic diversity, it has options. If a disease emerges, some individuals will have genes that confer resistance. If the climate changes, some will be better adapted to new conditions. Diversity is insurance against the unknown. Humans have less insurance than we should. We're all similar enough that a disease that affects one person will likely affect most of us similarly. We lack the genetic variation that might protect subpopulations. If a new pathogen emerges, a virus, a bacteria, a fungus, and it's particularly effective against human biology, we don't have as many genetic variants that might confer resistance. This isn't hypothetical. COVID-19 showed us how a novel pathogen can spread through our interconnected, genetically similar population. And that was a mild example compared to what could happen. We're one pandemic, one climate shift, one supervolcanic eruption away from another bottleneck. And next time, the die roll might come up differently. There's a lesson buried in the ash layers, preserved in ice cores, written in our genes. We're not invincible. For all our technology, our satellites and computers, our cities and power grids, our medicine and agriculture, we're still biological creatures dependent on systems we don't control. The sun, the climate, the stability of the ground beneath our feet, the composition of the atmosphere we breathe. 74,000 years ago, those systems failed. And everything our ancestors had built, every community, every relationship, every plan for the future, became irrelevant in the face of volcanic winter. What mattered was simpler, more fundamental: food, warmth, shelter, water, cooperation, the ability to adapt when everything you knew stopped working. Those survivors, your ancestors, my ancestors, everyone's ancestors, didn't have satellites to warn them. They didn't have global supply chains or emergency response systems or scientific models predicting atmospheric recovery. They had stone tools and fire in each other. And it was almost not enough. Today, we face different threats. Some natural, like Toba, supervolcanic eruptions, asteroid impacts, pandemic diseases emerging from animal populations, or thawing permafrost. Solar superflares that could disrupt our electrical infrastructure. But we've also added threats of our own making. Nuclear winter, the scenario where nuclear weapons exchanges create smoke and soot that blocks sunlight, triggering cooling similar to volcanic winter. The mechanisms are identical. The effects would be catastrophic. And unlike Toba, which required no human decision, nuclear winter would be a choice. Climate change itself presents cascading risks. Not just warming, but instability, disrupted weather patterns, failed harvests, mass migrations, the potential for conflicts over resources, and in response, the temptation to try geoengineering to deliberately modify the climate, which brings its own enormous risks. We're more powerful than our ancestors were. We have more knowledge, more tools, more ability to shape our environment. But power without wisdom is dangerous. And wisdom, real wisdom, requires humility. Humility to recognize that we're part of systems larger than ourselves. That the Earth operates on scales, temporal and physical, that dwarf human civilization. That catastrophe doesn't care about our plans or our hubris. 74,000 years ago, the survivors were the ones who stayed humble, who adapted, who didn't assume tomorrow would look like today, who planned for the worst while hoping for the best. We've forgotten that lesson. We build cities in floodplains and wonder why floods keep getting worse. We construct coastal infrastructure and act surprised when seas rise. We depend on computer systems vulnerable to single points of failure. We create supply chains so optimized for efficiency that one disruption cascades into crisis. We live as if disasters are anomalies, as if normal is permanent. Toba teaches us that normal is temporary, that the baseline can shift, that the world we know is not guaranteed, and that survival requires more than technology. It requires community, cooperation, the ability to share resources when they're scarce, to care for the vulnerable, to preserve knowledge, to maintain hope even in darkness. These aren't technical challenges. They're human ones. There's something remarkable about the archaeological record from the Toba period. Despite the catastrophe, despite the darkness and cold and mass death, humans kept making art. Ochre use continues through the bottleneck. This red pigment, painstakingly processed from iron-rich rocks, served many practical purposes. But it was also symbolic, decorative, human. Shell beads appear in the archaeological record, perforated, strung together. These took time to make. Effort. They served no survival function. They were beautiful. In the midst of the worst disaster our species had ever faced, our ancestors still made beautiful things. That's not trivial. That's profound. It speaks to something essential about human nature. We don't just survive. We find meaning. We create. We express ourselves even when, especially when, times are hard. Art in darkness is an act of defiance. A statement that we're more than just biological survival machines. That even when the world is dying, humanity persists not just in body but in spirit. Those beads, those ochre-decorated tools, their messages sent across 74,000 years. They say, we were here. We suffered. We endured. And we remained human. What did they think about, those survivors? What did they feel? We can't know their thoughts, but we can know they were like us. Same brains. Same capacity for fear and hope and love and grief. They watched people die, friends, family, children. They felt hunger. They felt cold. They felt despair. But they also felt something else. Something strong enough to keep them going through years of darkness. Maybe it was love for their children. Maybe it was loyalty to their group. Maybe it was simple, stubborn refusal to give up. Maybe it was hope, irrational, impossible hope, that things would get better. Whatever it was enough. And because it was enough for them, we exist. Every choice they made ripples forward. The decision to share food instead of hoarding it. The choice to care for an injured person instead of abandoning them. The effort to teach children skills and stories. The maintenance of fire through storms. Small choices. Human choices. Choices made in darkness with no guarantee of dawn. Those choices created us. Here's the thing about that darkness, 74,000 years ago. It ended. Not quickly, not easily, but the sun came back. The sky cleared. Life returned to a scarred planet and began the slow, patient work of rebuilding. And humans, resilient, stubborn, impossibly determined humans, not only survived but thrived. From that bottleneck of a few thousand individuals, we became millions, then billions. We spread to every continent. We crossed oceans. We climbed mountains. We adapted to deserts and tundra and rainforests and grasslands. We developed agriculture, transforming wild plants and animals into domesticated species that could feed settled populations. We built villages, then towns, then cities. We invented writing and mathematics and astronomy. We created music and poetry and philosophy. We built civilizations that rose and fell and rose again. Sumeria, Egypt, Greece, Rome, the Maya, the Mongols, each leaving its mark, each adding to the accumulated knowledge and culture of humanity. We figured out how to harness steam, electricity, nuclear energy. We developed medicine that extended lifespans and reduced suffering. We sent humans to the moon and robots to Mars and probes beyond the solar system, carrying messages to whoever might find them eons from now. All because some people, thousands of generations ago, refused to give up when the sun disappeared. They didn't know if it would ever come back. They had no scientific models predicting atmospheric recovery timelines. They couldn't know that in a few years, or a few decades, or a few centuries, the world would heal. They just kept going. Every morning, they woke up in a cold, dark world and decided to survive one more day. They made tools even when the future seemed pointless. They taught their children even when children were dying. They maintained fires through storms and wind. They cared for the sick and the elderly even when resources were scarce. They told stories even when there seemed to be nothing left to hope for. They chose hope over despair, life over death, tomorrow over today. And that choice, made over and over by thousands of people through years of darkness, is why you're here right now, listening to this story. That's the gift they gave us. Not just genetic survival, but something deeper. A template, a proof of concept, proof that humans can endure the unendurable, that we can adapt to conditions that seem impossible, that we can maintain our humanity, our compassion, our creativity, our cooperation, even when the world is ending. We carry that in us, not metaphorically, actually, in our genes, yes, but also in our culture, in the stories we tell, in the way we respond to crisis. When disaster strikes, earthquakes, floods, fires, pandemics, watch what people do. They help each other. They share resources. They organize. They cooperate. The worst of human nature emerges sometimes, yes. But so does the best. And often, the best wins. That's Toba's echo. The survivors teaching their descendants how to survive. We stand today at another threshold. Not a supervolcanic eruption, not yet, but a slower catastrophe of our own making. Climate change, ecological collapse, biodiversity loss accelerating at rates not seen since the last mass extinction. The causes are different from Toba. This time it's not geological forces beyond our control. It's us, our choices, our consumption of fossil fuels, our transformation of landscapes, our industrial agriculture, our population growth. But the effects, disrupted climate, ecosystem collapse, mass migrations, resource scarcity, echo what happened 74,000 years ago. And the question is the same. Will we survive? The answer is, probably. Humans are resilient. We're adaptable. We have technology and knowledge our ancestors couldn't imagine. If anyone can navigate this crisis, it's us. But humanity survives isn't the same as civilization survives. It's not the same as most people survive. It's not the same as we continue the trajectory of progress and prosperity. Toba-level disruption today wouldn't end humanity, but it would end the world as we know it. The global economy would collapse. Billions could die. The survivors would inherit a diminished, damaged planet. Is that acceptable? Is survival enough? Or do we want better? The Toba survivors didn't have a choice. The catastrophe came without warning, without any possibility of prevention. They could only react, adapt, endure. We have a choice. We can see our slow-motion catastrophes coming. We have decades of climate science telling us what's happening and what will happen if we don't change course. We have ecological data showing extinction rates and ecosystem decline. We have the knowledge and technology to address these challenges. What we lack is the will, the collective decision to act. And that's where Toba's lesson becomes critical. Those survivors 74,000 years ago succeeded because they cooperated, because they shared, because they prioritized the group's survival over individual gain, because they planned for the long term even when the short term was desperate. Today, we need the same. Not because we're facing sudden darkness, though we might, if a supervolcano erupts or an asteroid strikes, but because we're creating our own slow darkness, and the only way out is together. International cooperation on climate change, shared resources and technology, protecting ecosystems and biodiversity, building resilience into our infrastructure and food systems, reducing our vulnerability to single points of failure. These aren't just policy prescriptions. They're survival strategies. The same strategies that worked in the darkness after Toba. And maybe that's the real lesson. The darkness isn't the lesson. The survival is. On a clear night, far from city lights, look up. Those stars you see, they're ancient light. Some of those photons have traveled for thousands of years to reach your eyes. They left their source when our ancestors were huddling in caves, waiting for a sun that seemed like it might never return. Those same stars looked down on the Toba eruption. They saw the ash clouds spread across the planet. They witnessed the dying forests and frozen rivers. They watched as a species called Homo sapiens teetered on the edge of extinction. And they kept shining. Because that's what stars do. They endure. They burn through darkness and distance and time itself. They exist on timescales that make human history, all of recorded civilization, a brief flicker. From that perspective, what does Toba mean? to the stars, to the universe, to the vast, indifferent cosmos. Nothing. One small planet having a bad millennium. Life disrupted, but not destroyed. The universe didn't notice. But to us, it means everything. It's the reason we're here. The reason any of us exist. The crucible that forged modern humanity. The moment when we proved, without knowing we were being tested, that we could survive anything. And more than survive. Persist with our humanity intact. Create beauty in darkness. Maintain hope through despair. Care for each other when caring seemed futile. That's not nothing. That's everything. We are, all of us, inheritors of an unlikely legacy. We exist because of choices made in impossible circumstances. Because of people who stayed human when the world became inhuman. Because of survivors who became ancestors. And now we're the ancestors. The ones making choices that will echo forward 74,000 years. The ones who will either pass on a living planet or a dead one. The ones who will either learn from Toba's lesson or repeat it. What will our descendants say about us? Will they look back in gratitude because we changed course in time? Because we chose cooperation over competition, long-term thinking over short-term gain, survival over profit? Or will they look back in sorrow at what we destroyed? At opportunities missed? At a planet diminished because we couldn't overcome our differences and our greed? The Toba survivors didn't get to choose their test. We do. That's both a privilege and a responsibility. 74,000 years ago, the sun disappeared. And somewhere in the darkness, a woman gathered her children close. She fed them what little food she'd found. She told them stories about the sun, about warmth, about the time before. She didn't know if those stories were lies. But she told them anyway because hope, even false hope, was better than despair. And somewhere else, a man maintained a fire. Hour after hour, day after day, feeding it carefully, protecting it from wind and rain. His hands were burned. He was exhausted. But he kept the fire alive because fire was life, and life was worth protecting. And somewhere else, a grandmother taught children how to make tools, how to find water, how to read the land. She taught them even though she would die soon, even though they might die soon, even though the world seemed to be ending. She taught them because knowledge, like fire, had to be kept alive. These people, whose names we'll never know, whose faces we'll never see, whose voices we'll never hear, made a choice. They chose tomorrow. And because they chose tomorrow, we have today. That's the story of Toba. Not just the catastrophe, but the response. Not just the darkness, but the light we carried through it. Humanity is that light. Small, fragile, easily extinguished, but persistent, stubborn, refusing to go out. 74,000 years later, we're still here. Still making tools, still telling stories, still teaching our children, still maintaining the fire, still choosing tomorrow. The 1,000-year night ended. But the morning it gave us, the morning we earned through darkness and suffering and impossible persistence, that morning is eternal. It's the morning we wake up to every day. The sun that rises because the sun came back. The world that lives because life refused to die. The humanity that persists because people in the darkness decided that persistence mattered. So when you see the sun tomorrow, really see it. Not just glance at it, but truly observe its light and warmth. Remember that it almost disappeared forever. Remember that your ancestors waited through years of darkness for its return. Remember that you exist because they hoped when hope seemed insane. And remember that the next catastrophe is coming. Volcanic, meteoric, climatic, or of our own creation, and when it does, we'll have to make the same choice they made. Will we give up, or will we endure? Will we fracture, or will we cooperate? Will we despair, or will we hope? The Toba survivors answered those questions. They answered with their lives, with their choices, with their stubborn, beautiful, utterly human refusal to accept extinction. And their answer echoes across 74,000 years, a message in blood and bone and DNA. We endure. We persist. We survive. Not because it's easy, but because we're human. And humans don't give up. Even when the sun disappears. Even when the world dies. Even when hope seems impossible. We endured. That's who we are. The species that survived the 1,000-year night. The ones who carried light through darkness. The children of survivors. The ancestors of tomorrow. And the sun that our ancestors waited for, hoped for, died waiting for, rises still. Every morning. Without fail. A promise kept across geological time. That darkness ends. That life persists. That dawn always comes. Always.